On this channel, we focus on the modeling, control, and simulation of power systems. Through a series of lectures, you will learn how to model and simulate power systems using textbook examples, benchmark systems, and large-scale practical grids. Topics include power flow analysis, which is used to calculate the system operating point and voltage profile, as well as transformer equivalent circuits, transmission lines, reference frame transformations, and grid code requirements. We model synchronous generators and their associated control systems, such as governors, automatic voltage regulators, and power system stabilizers used in conventional power plants. We also model power electronics converters, including two-level voltage source converters and modular multi-level converters for use in power stations and renewable energy applications. In addition, we examine different types of wind turbines and explain how they operate under maximum power point tracking and deloaded modes. Other topics include inertia emulation, power oscillation damping, and control strategies that enable 100% renewable power grids. Each lecture provides the equations and parameters required to reproduce the presented results. With these tools, you will be able to perform small signal and transient stability analyses. For example, you can study the integration of wind farms and multi-terminal DC systems, analyze frequency stability challenges in power systems with high renewable energy penetration, and investigate subsynchronous oscillations in conventional and wind power plants. Thank you for watching, and welcome to the channel.